May share a screen. You are able to see my slide?
Yes, sir, it's visible.
Okay. So thank you for the introduction. And good morning to everybody. Today I'm going to talk about one of the sort of hot topic, engineering or science degree and employability. Okay. This is last year survey report. Okay, 80% of Indian engineers not fit for the jobs that are emerging. Is very important. The jobs that are emerging in the field of AI and data science. Okay, and the survey says now last 10 years. You can read that one. This article you can take and read. Okay, there is no improvement in the situation. So what exactly has gone wrong? And this is I think few days back news, Indian Express. Okay, almost 75% of Tamil Nadu engineering seats still vacant after 3 rounds of counseling. Okay, so what is the reason? And what are the changes required for the curriculum and pedagogy? So that is the thing I am I can say prepared for this talk. If you want the answers, this answers right from now 2009. There are so many books explaining about what is the future, what type of skill, okay, the students should acquire. All those things are there in several books, but somehow academicians and our politicians and those people, ICT, all those people, they didn't care that one. Now they are facing a problem, and this type of news are coming. Okay, so we'll go through now what are the things in this book. The first book, the fourth paradigm. Okay, actually is the person Tony Hay. He was a Microsoft scientist. Okay, now he is no more. I think around 2012-13 he died. Nobody know how he died and all those things. Okay, and this book is downloadable. It's a very freely available book. Okay, just type this for the fourth paradigm. Okay, you can get into the site and you can download. Okay, please go through. Written by a computer scientist only. So he is talking about scientific paradigm. Sorry. 1 second, minimize. Science undergoes periodic paradigm shifts instead of progressing in linear and continuous way. Okay, and occasional invention of new theories and ideas unravels the old paradigm and establish a new way of doing science. So this was happening, okay, slowly, but people now in charge didn't know, I can say, take care of that one, to put into our curriculum and change in pedagogy. Nobody cared about that one. That is the reason what we are facing now this situation. Okay, so first let us talk about now what are the modes of doing science or pillars of science. First is observation and experimentation. Okay, that is how our forefathers started now doing science. Celestial mechanics, mapping out the sky, because people need to travel across sea. Okay, there and now doing agriculture. We need look at the sky. Okay, then map the sky, then changing of the season, all those things we need to do. So observation and experimentation was our initial mode of science. Then came, after collecting all those so much of years, 1,000 years of data collected by travelers, okay, faring across sea. Based on that data, we made a set of rules that we call now theory. Okay, simple set of rules. Basically, almost all of them described by some basic mathematics. Okay, so Kepler's laws of motion, Newton's, then which finally ended up in industrial revolution. So theory is our second mode of science, and based on theory, we could predict a lot of things. And this revolution just was the result of this theory. Then 1980s started. Okay, another. Okay, we call this as sort of a paradigm shift. Computation and simulation. Suppose if you want to study climate change, you can't do any experiments here. Laboratory experiment is not that easy. Okay, and theory was now so complex. It was not like Newton laws of force equal to mass and acceleration. That climate you can't put into that type of simple equations. Okay, so first of all, it is highly non-linear system. So many variables are involved. Okay, so doing experiments regarding this climate was impossible. Similarly, galaxy formation you can't do in lab, but along the theory, computation and simulation, because they are now following Newton's or the whole thing was now following some fundamental laws. Okay, but number of variables involved were very large. So theory, computation, simulation could help us to understand climate change and galaxy formation. And on the way came now the very famous sorry, this butterfly effect in nonlinear dynamics, which says if a butterfly flap the wings here, somewhere else it may cause a tornado. Okay, because this climate system is highly nonlinear. So all those things we could study through simulation only. And in fact, I think 1982 something, this Nobel Prize was given to Ken Wilson in I think it is in computational modeling and simulation. Okay, and that now is the beginning of nonlinear science. And you might have heard of fractals, chaos, etc. Okay, all came out of this computation and simulation. Okay, so this is our third pillar of science. Okay, now that resulted in something called computational sciences, high-speed computing. So these three together: experimentation, theoretical analysis, and numerical simulation. Okay, putting together, we are calling as now computational science. Okay. Now, see, these are the generations of computers. 1981, something wax, and now what are in today's computers is 2 core times, okay, faster. Okay, that much of computing power is there. That only finally enabled us this now third mode of now computational sciences. But still, in India, it is very slow to pick up this area. Okay, I will be telling more about it later. Now, a fourth paradigm. So the book is telling now that Tony Hayes' book is about okay, the fourth paradigm. So he said now this new flourishing area is coming, and that is a new kind of as a science which he called now data-driven science. Okay, because this the status actually was 5 billion devices used by now 1 billion people. So data was okay produced like anything, and stored and analyzed. So he was telling all these things in this book. So everything is taken from this particular book. Okay, so data science, and this reason for this one maturing of sensor technology, transforming all sciences into data poor to data rich. Okay, all sciences including now biology. I will talk about biology later. And here now you can see 2 pictures. Okay, one is Australian square kilometer array. Okay, of used by astronomers. Okay, producing now massive amount of data about the sky, and you may ask now why all these are required for our survival. Okay, it is a must. Okay, one comet or no the type of no celestial object no is enough to destroy under our the civilization. So before it hit the earth no, we should be able to go and destroy it. Okay, and the CERN's Large Hadron Collider. Okay, that using which now people did a lot of experiment about fundamental physics. Okay, so this experiment done, say suppose this is done 1 hour, it will produce so much of data. It will take now 6 days, sorry, 6 months to okay analyze that data. So you may have heard of God particle or those things. So this is data-driven science. So he was telling about now data-driven science. Okay, long back, and in 2009 I told, and he was telling by 2015 system is now become so much important. Okay, so attention should be given to that. Finally, it has happened. Okay, and the collected data is put in a database, and you can go here and see. It's an open database only. Again, there is a software given. Okay, you can put yourself anywhere on some galaxy or some planet you can put, and you can, if you look at the sky, how it look like. Okay, that type of things you can have it actually. Okay, it's all initiated by this person. He's the Tony actually. So all this is explaining in this fourth paradigm. Okay, data is so much that nobody can fully explore the data collected and put in this one. This database. And he was also telling about very soon our mobile will be containing a lot of sensors, and this will be collecting huge amount of personal data. Okay, finally useful for healthcare and so many applications. So see, so it is going to come probably within 10 years. Okay, your mobile probably will be your doctor. Okay, collect all this one, put into some cloud, and cloud there will be sitting some agent. He'll be analyzing all your data. Probably can be the cloud can be near home itself. You can have a, if you your data, if you need privacy, can be that way. Okay, and when if required, you can summarize data. You can give to your doctor. If so, that type of things are going to happen. Okay, we are also talking about now our about the climate, and is that now very soon what is going to happen? It's already happening now. Underneath the sea now, or sea is only basically affecting our climate. Okay, so sea monitoring by putting sensors all over the sea. Okay, we'll be able to really understand now the climate and the climate change. Okay, so he talked about that type of network. Okay, and that is required for as a understanding the living organism see, and also okay, total finally now for our survival it is very important that we monitor the health of the sea. And he was also talking about, okay, by 2050 something like this will happen, USB to the ocean. Okay, so we'll have now 3D type of now screen, 3D screen. Okay, and kids will be able to see underneath the sea, anywhere, whatever your sensors is capturing online, they can see. Okay, so that type of a future he was talking about now in this book. So very at least now 50 years ahead you can see what is going to happen. That type of. Okay, now AI and data science together. So that is a fourth paradigm. Now we are moving to data science. Now then AI became recent years became very popular. So these three together now is going for now your next paradigm. Okay, probably people call it this. Simply put this way, we are moving into that fifth paradigm. Okay, already we are seeing now its results. AI is a very core technology. Okay, it's a lot of power. It has beaten now this Go player 2000, I think in the 16 or 21. Okay, one of the toughest game in the world. You know that AlphaGo. The problem people were saying now is not. This is like a black box. Okay, so it is not able to explain why it has taken a certain kind of a decision. Okay, so why do you do that? When do you succeed or fail? So that type of things can't be I can say obtained from a neural network. He can't tell now why it has taken a decision. Okay, some output has come. You say so you can take some decision. Okay, what is the reason for that now that decision? Okay, so these types of things are not answered. Okay, so this is a slide I borrowed now 2018. Now it is getting now this problem is also getting now slowly getting solved. Now explainable AI result you should be able to explain, like decision tree. You might have heard of decision tree. It's a very simple algorithm. Okay, where everything is expressed in terms of your knowledge is expressed in terms of if then else. Okay, that type of thing, which is is basically I can say the classical machine learning algorithms. All are explainable. You can tell why certain rules. Those things we could do, but now neurotech is a totally different kinds. So this is now getting solved. Now few days back, I think 3-4 days back, one of the biggest problem biologists were faced in the last 50 years. Because we call it a grand challenge problem. Okay. So computing for solving the grand challenge problem. Okay. So this is now solved. Okay. Basically, given an amino acid sequence, we should be able to predict. Okay, the 3D shape of the protein. So in the body now. first from this nuclear cell, the body will be first creating this amino acid sequence. The sequence now start or now this amino acid start folding on its own. So far we don't know what is the basic principle behind that folding. Somehow it will fold in a very specific way, finally produce a 3D structure, and 3D structure of this protein decides the whole function. So in our body now we have thousands of this type of protein, which is now whose function is not really known, and there is a pathways of interaction between these proteins. This protein now may interact with something else, still help formation of something else. A lot of things. I don't know the full biology, but still they say there is a network of interaction taking place. To know all these things, it is a must that we know the 3D structure. So conventionally, what people were doing is they were using a cryptography type of physics type of thing. Finally, you get a diffused image. Based on that one, you should figure out. Okay, it will take now years actually to get okay, one 3D structure of one protein. Okay, and it's very time consuming. And crores of rupees, I can say, the cost of the equipment is now so high. So not everybody, every lab can afford now to have that kind of lab. But now an algorithm could solve it. Okay, but with the massive computation, we could do that one. So finally, I started solving, okay, the grand challenge problems that we are facing. Okay, there are so many such things. Other thing is now day for yesterday or now you know is Madhurumi in your local papers. You might have seen this news. Precise genome editing with AI, and Singapore approves now a lab grown me product called now the company name I think Eat Just. Okay, so in lab based on real cell of the some animal, they can produce now corresponding meat. Okay, so this is going to be a game changer. We need not now kill animals for okay this meat and many other things. And in fact, now this years now Nobel Prize has gone to biology. Nobel Prize has gone to chemistry. I don't remember. Doubtna, a lady who pioneered the something called CRISPR technology, CRISPR. It's basically genetic technology. Nobel Prize has gone to, and she was telling now few years back, there is a book. I forgot her book's name. Okay, later I will tell. That book now she's telling within 10 years, whatever you eat, okay, maybe CRISPRed food produced by CRISPR technology, gene editing technology. Okay, and AI is taking care of now all the issues like they are studying all the so-called safety issues and all those things. They can now very precisely they can edit and also find now whether it will have side effect or whatever. So AI is helping in a big way in coming out with the deployment of now this technology. Okay, so very soon all the country will start now producing this. So this is going to have a major change in again the climate. Okay, because US, these people are now eating a lot of meats, and vast area of land is basically utilized for this creating this fodder, the grass and all those things. And based on that one, then now this cows now produce a lot of methane, okay, which is producing now or now causing now this you can say this greenhouse effect and all those things, rising of temperature and all those things. So we can now little bit now the technology is allowing us to repair now whatever now last 200 years of our what you can say intervention in environments just now negatively affected the environment. We are in a position to repair it. One is this one, though initially we are seeing as you are getting a meter from this one, but now long-term effect is long-term result effect out of this one will be going to be very high. Okay, so computing. Okay, these three things together is now important thing. AI, data science, and the computing together can solve now world's many of the problem. One is energy problem, poverty, water, then complexity. Complexity in the sense now we have now something called complex networks. Our body itself now, protein interaction, all those things, all the that type of problems. Okay, complexity based now they have so many variables interacting in a nonlinear way and producing some results. Okay, so all type of now that the complex system we can now analyze using this computing power. Okay, so these are the direction in which now the technology is moving. Okay, but okay, this about now computing alone is not the solution to our problems, but now more than our net can help. Okay, but the problem is now our education system conveniently ignored now all these paradigm shifts. So much of things were happening, and those scientists were not telling. All the world thinkers were telling. Okay, this now science is moving so fast. Our education system is not keeping pace with the technology, and suddenly there will be a problem, and problem has come now. We are facing it. Okay, so now I need to talk about this the first book and the second book is now published now 2000 morning. So previous slide you can see. Okay, so there is a chapter on education. Okay, so what this person says is now we have now in every field sort of abundance is going to come. Every field can be abundance of data, abundance of now all sorts of things, tools and resources. Okay, for example, in your college now probably now there are so many electrical labs, electronics labs. Okay, but we are reached a situation where with now with 10,000, 50,000 rupees, you can have a lab on your home. Okay, for doing all sorts of experiments, your home itself. You need not go to lab for doing now the simple electronics experiments. Okay, so we have this Adalem 1000. We are using it now for our new course. We totally taken away now concept of separate lab. Okay, not this one, separate computer lab. What is the meaning of a separate computer lab? Your mobile is now more powerful than okay a 1980s supercomputer. And the book you are learning now, or whatever textbook or those is now, most of things may be written on 1980s. Okay, and 1980s supercomputer is your mobile. Okay, but we have now the concept of now this ordinary lab. So this Adalem 1000 is an analog device only. It's cost only around 4,000. All the electrical experiment. Only thing is now the power you can't put now 20 watt, 30 watt, all those things. Okay, low voltage only. You can do your experiments, but now you can do all experiments. What is required now electrical? Then electronics. Adalem now 2000 costs around 6,800 rupees. Okay, and there is a package Adalem P, all the components. Okay, whatever an electronic engineer does now in 3-4 years of engineering. Okay, that you can do from home itself. Probably now you can now a few students now can share all those things. All now accessible in the sense a few students now can buy together. Okay, and share. And this is communication system. Adalem now Pluto. Okay, you don't look at a separate lab. You can communicate. Only thing is now distance will be small. 100 meter now you can transmit and receive all sorts of communication experiments. Much more than whatever a communication engineer does now in lab, but this is now this converted to a PC. Okay, and there is a open source software is available. You can know in and out of communication engineering. Okay, using this. And if you recur now, this of course is having some hardware using Adalam. This one now you can have now build now your own hardware if you want to know with the discrete elements. You want to make your hardware. Okay, everything is possible. So Adalam 2000 and Adalam Pluto you are receiving or transmitting, and now it is detailing your signal. It goes to a PC. You are doing. You can write now your own algorithm for anything. Okay, that is advantage. Finally, you are doing now real communication. Only thing is most of the things are happening in computer. So it's usually we call now software defined radio. Okay, it's contain only very minimal hardware. Rest everything happening now is in computers only. So the way you can learn engineering, okay, it is now so much of facilities available now. But we are learning now 1980s way. Okay, and I didn't say drones. This is a special kind of drone, $50. It can be using a program now. You can control this. In fact, there is a package inside MATLAB. MATLAB is my Matrix laboratory. It's a package. I think every education institution is having maybe license version on that one, or people are having India now. Every zones are having a pirated version. There is a toolbox. Now it is developed by MIT. Okay, you can do now all sorts of very complicated control system experiment using this drone. $50 only. Okay, and previously I talk about now software defined radio. Okay, that you can Adalam Pluto. Okay, and there is another version. Only thing you can transmit, you can only receive. Okay, just now it's called RTL. It's only $20. So using this one and a PC, you can do all sorts of communication, again engineering experiments from home. You don't have to go to a lab. Okay, so $20. And if you are using a Raspberry Pi now, some FM signal transmission is possible. We have done all sorts of experiments. Okay, in the first year itself. We are not now doing this one conventional EC people now, EC students. They are doing this for some systems, etc. We have pushed down to second and third semester. Most of this is possible. At least now I can say every engineering institution it is possible. It's a Pluto, same now hardware. Previous now that previously I told now is by unlocked devices. You can do now two-way communication system. Okay, and this programmable because there is a programmable hardware now. You can do program through here now from PC now. You can write program and push now the code into this one. So that type of things are possible with this. Okay, and another thing what is happening is now DNS. You can see now this is a big area for computer science people. Okay, so much of data will be now going to be generated using now. We have something called DNA desktop sequences available now. We have this one. We are going to develop further. Actually, it's a UK-based company. Okay, DNA RNA sequencer. You don't require a big lab. Just like now, 1950s, a computer occupied one full building. Okay, this DNA sequencing lab. 1980s. Okay, again a full building. Now it is something you can keep in a pocket. Okay, only thing is you require something else for no DNA preparation, and this is going to be an extremely big field for computer science people. Because now computer science people or no your MCA, master computer everything, you are solid. People were getting training only now business problems, ordinary business problem, which don't require much mathematics. Okay, now the situation is changing. Okay, many new generation companies are coming, which may be employing now probably most of you. Not now traditional companies like okay, big companies like TCS, whatever. I don't remember the now the company's name. Okay, all the big companies. There will be a very big number of now small companies. Okay, coming up based on all this new technology. Okay, then 3D printing. Okay, once now we have set up like this, even now even metal based 3D printing is coming. Okay, maybe a little costly, but plastic based is with the 1.5 lakh. Now you can get 40,000 itself is the Chinese version. Okay, extremely good version. Okay, so it is going to change now this digital manufacturing. Okay, then this probably you know Arduino, Raspberry, etc. So all these things should have been now directly put into first year of even now +1, +2, and first year of engineering. Okay, so these are the new tools which can now change the the whole learning process. Our learning is all textbook based, not much, and that is the reason why the first this one 90% of current engineers are now useless. I should use the right word, useless for now new jobs that are emerging. Okay, I'll tell some more reasons. Okay, and this here now IPython notebook and all those things. Okay, so this type of tools, both software and hardware, should have changed our now under the pedagogy, the way we conduct now the classes and learn. But now that has not happened. Okay, now let me talk about now this about actually this is mentioned on this abundance book, whatever I told now. So these things are happening. So big change should happen in our education system. So there's a chapter not tell that one. He's also telling about now what exactly the problem with the our education system. He says this model after now industrial revolution. Let me read out. Our current education system was forged, built in the heat of the industrial revolution. A fact that not only influenced what subjects were taught, but also how they were taught. Standardization was the rule, because now common syllabus, common question paper. So the system was not considering a person individually. Standardization was the rule. Conformity the desired outcome. Okay. Students of the same age were presented with the same material and assessed against the same scale of achievement. Schools were organized like factories. The day broken into mainly evenly marked periods, well signaling the beginning and end of each period. Even teaching, as Ken Robinson put, is a famous person in this who popularized computing in schools, put in his excellent book, Out of Our Minds, Learning to be Creative, was subject to the division of labor. Like an assembly line, students progress from room to room to be taught by different teachers specializing in separate disciplines. Okay, this is okay. And the main thing now, okay, this is you can read this book now. It's a beautiful chapter. Even audio book is available. You should understand now. So we are taking as it now. This is the standard method followed forever. No. Okay, with the current resource available now, we can change our entire pedagogy. That much of resource are available. Okay, and individualized. Teaching should be for individual. We have to understand the capability of each person accordingly. So there must be some provision for for taking into account every individual, every student. But the current standard exam, standard textbook, standard this one, and some final written test. Okay, so he says now in future, okay, able to ask the right question is the most important thing. Okay, today's school their emphasis on extreme conformity are killing creativity. Okay, let me read out. What we know is that industrialized models of education, with its emphasis on the rote memorization of facts, is no longer necessary. Facts are what Google does best. Okay, so we need not have questions now which does all those things, but creativity, collaboration, critical thinking, and problem solving. Every industry needs this one now. But tell me, in your pedagogy, where is the provision for, first of all, collaboration? You are collaborating for finally only for now when you are coming to final semester doing some projects. but this is a collaboration is a fundamental skill. Right from starting now, you should practice it. Okay, critical thinking and problem solving. That is a different story. So these skills have been repeatedly stressed by everyone from corporate executives to education experts as a fundamental required by today's jobs. Okay, but all these are totally ignored. Okay, in future now technology is moving very fast. Okay, already it is now. Okay, so your all these skills finally enable you to know ask the right question and solve it. Okay, now comes to the third book. The very famous person, I should not know. This book should be taught. This Sapiens, I don't know, is the author of Sapiens, Yuval Harari. Malayalam, I see now so many people are making videos. Okay, Malayalam videos out of this book. Okay, so many are doing it. At least 2-3 hours I have seen. Okay, excellent. This should be taught to everybody. You will see the entire history of now in a new perspective. We know only now. I don't know Marxian way of interpreting history and all those things. So I want now, or we are telling our students here, let everybody go through this particular book. And he's telling education is not preparation for life. That is what most people think. For a year you will learn. Okay, then that is enough for your next 50-60 years. Okay, that now is over. That period is over. Okay, so 4-year learning or a 3-year learning or a 5-year learning, whatever. Okay, and then stopping is not going to be an option. Okay, you can never stop learning. Education is not preparation for life. Education is life itself, because technology is moving very fast. So requirement will change fast, and you should be able to change, adapt, reinvent. Upskilling every year. So a lot of changes going to happen now in industry. Probably industry may demand like this. You upskill yourself first and work in a company for 2 years. You again go for upskilling next 2 years. Then come back. Okay, by that time now technology must have changed. You prepare that way. So our idea of now this permanent job type of thing is going to be future 20 years now. Probably within 20 years now you can expect massive change. Okay, the way you are seeing now is not the real future world, or now you can't just extend what is happening now. Okay, this may be like this. You can't do that way. Okay, that much of disruption is going to happen. Okay, it's somewhat difficult to predict actually what will be the world after 20 years and what is the skill you require that time. You have to always look on for that one and continuously update yourself. That is the only way of for now survival in 21st century. Okay, anyhow, my topic is this one. We ignored all these things. So what we can do? Okay, so even now its consequences now disastrous. Now 90% are useless. Yes, now the question is now how it has happened and what we can do. And now even IITs are not spared actually. Okay, you may think that now IIT students are so bright that this and all. Now this one you can hear, but now reality is different. Okay, so there is a professor. Now you can see so many articles by this person. Okay, do all IIT students get job in a core company of their chosen branches of studies? Suppose this person is chemical engineering and one more department. Okay, he says no chemical engineer is getting from IIT good core company job. Even a company comes, company pay only very okay sort of average salary, small salary. They are not getting a salary like Google or Microsoft. Okay, so this disparity between the salary of different branches so high now. Okay, so and this now 1 crore job and everything now 1 or 2 will get, but now thousands of people are studying in IIT, but now they hype that one. So go through this. I will send this slide. The undergraduate programs in IITs focus on teaching traditional science and engineering branches in a conventional manner. I mean, even IIT is lagging now in updating technology at least. Okay, even as the world turns, is very important in a world for you. World is now multidisciplinary. You can't have no branches like chemical, civil, mechanical, and all separate. Okay, in 4 year now you can learn all the four. Now we have a syllabus now. We paid now with a lot of fight. We have got it. Okay, electrical, electronics, computer science, and mechanical put together. We call it as CSEA for another reason, but okay, we are really putting now all 4 branches put together, and 4 year notice quite easily we can impart now that knowledge, but there is a lot of other changes in the pedagogy which I will. Okay, so artificial intelligence and AI are now assorted data technologies. Okay, so even IITs are lagging now because our own like now Indians. So once they get job, they don't change. Okay, conventional manufacturing is undergoing rapid change. Routine objects are manufactured by robotic assembly. Okay, and fewer supervisors than ever. So every conventional engineering now jobs are conventional now. This one jobs are coming down. Okay, so unless you prepare yourself a multidisciplinary way, you may find difficult now in surviving. Getting survival is might be possible because of okay, you may get now free food, okay, and free housing. Probably that is the future now. Government may give that one, but a good, enjoyable job that is not guaranteed. Okay, so for that you should be a multidisciplinary person trained in that way. Okay, so he's a chemical engineer. He says now chemical plants to need fewer employees. Okay, to the development of sensors and Internet of Things technologies. Similar efforts can be seen in construction. Okay, so every conventional engineering now students are not joining. That is the reason morning. Sorry, the earlier slides I have shown. Okay, 75% seats are vacant. Reason is this. Okay, and this is now written by the professor. So you should really read this one. The general message asserted by students is the domain knowledge of in traditional branches. Which are the traditional branches? Electrical, electronics, okay, mechanical, civil, chemical. Okay, and now slowly computer science this also will face challenge. Time being now, probably next 5 years, but after 5 years, even traditional computer science people won't get jobs, good jobs. I mean, okay, I will tell you the reason. The burnout on incompetence at the time of entry is now sustained by this rationalization. Students become even more indifferent to academic work, someone even hostile, and in extreme cases, some slide into a permanent state of laziness, sloth, and distraction. The more energetic ones get pushed into alternate interest. That's why now many of the IIT students now after BTech now they go for some management and all those things. They understand getting a good job in their respective domain. Mechanical, okay, chemical is not that easy. Good job, good salary job compared to current CSE students with good grasp in AI and data science. That salary will be huge, and these people are the same caliber only, mechanical and probably computer science, but now salary difference is okay. And this is a report from now written by students. You can now the previous this process, this website you go to this, click on here, and there is a link to okay students write up. Why don't we study at IIT B? Okay, because now they are these people who are entering there are intelligent. They immediately understand whatever they are learning is irrelevant for their future. Okay, and the process, though from outside we see all process are big IIT process and all those things, but these people say this they are not that great. Okay, in a very conventional way coming and teaching something, but there are of course there are extremely good teachers also. They teach in such a way that students really learn things. Okay, both are happening there. And how this is a good article, okay, exposing what is happening inside an IIT. Okay, then this Professor Mehra asked the director of IIT. time now. Okay, I'm going to discuss. Okay, quickly I will finish. IIT Bombay about now Institute opinion on most undergraduate taking up now careers in not even remotely related to their core fields of study. He replied that institute was fine as long as students continued to contribute to the society in a minimal way, but not working in some other fields. So this really a question: why we should spend now so much of money for IIT graduates? Because now getting an IIT graduate, government is spending a huge amount of money out of ordinary man's now tax this one, but now finally they are going in a different fields. Okay, this is a wastage of time. So IIT is now becoming now a wastage of now government's money. Okay, and this is another IIT professor now about autonomy. So what is now I'm telling now what is the reason for now this deterioration of quality of now our engineering or now science students in the country. Basically it is on autonomy. Okay, university now we have a highly rigid now university system, whereas IIT they don't have that one. Every faculty now is in the class, he decides everything. But now university system now is not that way. University decides everything. Okay, and faculty are now simply simply an employee, simply follow the rules. So that is especially mentioned here. Okay, a number of engineering colleges are affiliated to university, while teaching takes place in individual colleges. It's the university which controls the syllabus and also the examination, to written examination. That is the funny thing. Even if a practical examination is there, what the student learn electrical now lab is now how to connect to wires to machines and now switch on this one, take reading. What sort of engineering I don't know. I am also electrical engineer. After passing out only I learned. Okay, I am fooled by our engineering system. Okay, teachers are required to teach strictly as per the prescribed syllabus. It changes at a snail's pace, if at all. There is a fixed plan for the examination. So finally now everybody is learning for examination, not for upskilling. So this is what has happened. Okay, and the question ridiculous questions. Papers include now standard options just now answer any out of 6 out of question. Question themselves are mostly descriptive. Explain that. Okay, describe something. Draw the block diagram. Okay, out of this one now what you learn, right? Notes, short notes on. So everything now you can put in Google and you can get the answer. Such now papers are called now theory papers. Finally now our education system is killing now 4 years the prime period of now our students. Problem solving abilities central to engineering education. You do not get adequately tested at all. As an attraction, questions are often repeated across examination conducted now in different years. Okay, so as smart students, okay, get now very high marks now by going through all this now this one. Finally, you don't learn anything, but you get now 90% mark. It's quite easy. Okay, and a teacher who teaches now has no control over the even as the matters. Someone else is going to set the question paper, and some other one is evaluate the answer books. This type of now ultimately nonsense things. Once it was okay, because that time resources were not there. Okay, is spoiling now our entire education system. Okay, it is not uncommon to find that students now routinely bunk classes and attend now coaching classes or read the guide books, which provide now there is something called a book called I didn't say some subject without tests, examination without tests. So many books are there. Simply by that book read before examination now you can get 90 to 100% mark. Okay, so he again says now our teachers are just like an employee of the university, no power for anything. Job to be done, because and now suppose a teacher is taking something new, something now, then now they go to the last one. They feel deeply stifled. Tell me that their attempts to discuss real world life problems solving in class are often rebuffed by students as what being out of syllabus. Okay, so students now faculty can't do anything now in the current system. Okay, so this is now really killed, and now why we are feeling this one now, the new kind of job which is emerging. Okay, the current pedagogy won't help. Previously, what was happening now, all Indian software companies, all the big now, I don't have telling this, most of this one now, jobs of maintenance job. They have now data customers abroad. Now customer requirement, some changes here and there. That here the customers complain, now do something here and there. So all the sort of maintenance and now some cutting, pasting, and all those things. So that were our now most of our big company job. Okay, now it is changing. Now everything AI data science, you require lot of different skill. Okay, so we started as a center now 2003, and that time itself we understood. Okay, world is moving in a different way. So we now computational engineering, center for computational engineering and networking. Okay, so we started giving now a lot of emphasis for mathematics and computing, but that time students were not ready to join because now for them there is an easy way. Go to computer science department, learn some programming and some database and all those things. They were getting a job. Now situation has changed. Okay, now that won't help actually. Okay, so we told our management something now drastically we have to do. So we as a center now, we were conducting only MTech courses and research, 30 research scholars. At any time now, we used to have 30 research scholars and a few MTech. Okay, and now we didn't last though only 20 to 30 opted for our course compared to computer science or other departments. We maintain our standards. Okay, and whoever come here could get an extremely good job now. There are many entrepreneurs now. Okay, anyhow, we propose a beta course 4 years back. Last year we got it and named as now CSCI. Our dean gave the permission for this one. So what we are telling now is true for any management now. Okay, if they want to make their ailing departments, computer science may be okay now, but other departments over the years are likely to face big problems. Okay, so to survive only at present, at least next 10 years, computing and AI, okay, should be common for all, every subject. So that is what I'm writing here. Okay, you should not now, you should, these two are different actually. Computing and AI is not computer science. Computer science is about making computers work and all those things. But computer science is about whatever is possible with the computer, IoT and sensors. This is now, Dept now it is called now computing science. Okay, this and AI should be part of every engineering if you want to revive any departments. Otherwise, you can survive maximum 4 years, not more than any department I'm telling. And now this MIT, USA, okay, they started last year, 2 years back. We proposed that 4 years back. Okay, and we were knowing because we have a few students there in MIT. Okay, this now sort of thing is going on. I think thinking is going on there about now changing the pedagogy and now the subjects. So MIT announced now $1 billion plan to create a new college for AI, full institute for AI, which will be supporting now all other departments. Something like now we have science departments which support other departments. Okay, first year is meant for, that is one thing. First year is meant for computer science people only. Okay, and that has, since it is not really integrated with the engineering, that first year is a waste already. Okay, now what they say now, okay, computing and AI is going to be common for all engineering. Otherwise, if those departments which don't embrace this one, they will die. Okay, so this is the future. Computing and AI will be going to be common for those students will never get job. Okay, I never get a job now. I mean a good job in the respective field. Like you can go in some other field and do something. For example, you can go to BA. Okay, you can get no selling job or no HR job, marketing job. Okay, all type of that type of jobs will be there. But core job, no way, no escape. if you are not upskilling in computing and AI. Okay, so a process changer now. So what we have done is now our new CSEA, probably every college can adapt and adopt this. Okay, AI demands now every subject to be mathematical and computational. So all our subject now we have lab, but now there is no separate lab. Okay, daily basis will be given, everybody will be given assignments, and every week they have to present actually. So I'm telling that one. AI demands every subject to be mathematical and computational, physical experiment and design process wherever possible, but now electrical, electronics, many of the things they can do from home. So again, no question of what lab. Okay, class itself is now both your theoretical discussion, practical discussion, lab, hardware lab, software lab, class itself. One class will do for everything. Okay, except now for few probably mechanical here and there. Okay, but mechanical now is now becoming robotics. Okay, you can have a scaled robotics now. This one in classroom itself. Okay, in the current system now, first year is totally based to upset the students now pursued view of engineering. Course enables, because now their now pursued view of engineering is now when now somebody join for that is what a student feel actually. Engineering now, he will learn a lot of designing, he will do design things, now build things, all those things. Finally, when enter engineering college, you see is only question about now bugging up something and writing examination, nothing else. Okay, so that is the current engineering. Okay, so what we did is now to overcome this one, because we tested with the previously with the RemTech, so that it was a big success. Okay, programming is a fundamental skill. First of all, that is the one we are first will tell. Okay, now we teach, not teach actually, make them do assignment of 6 programming languages. Okay, starting from now Java, Python, MATLAB, R, all those things. Because now if you know for loop, while loop, if then else, okay, this something now should be taught at SLC level. Okay, you can learn now any other language. Then supporting packages are there for learning now AI and all those things. Now you have supporting now packages now each this one, so you can start using it. Otherwise, programming is not a big thing now. High school level itself now everybody should know programming, and we give programming now assignment now for each and every subject. This is the new CSEA, totally different from, we totally isolated from the other departments. Okay, we have faculty with multidisciplinary backgrounds. Our own we are dealing, because moment you outsource to some other departments, it will be diluted. Okay, project work for every subject. So now project work is not this one. Every, even a maths also now I give very heavy projects, and now some of these are first year itself now student published papers now going to IIT and all those things. I can show one of this one. Assignment with the presentation. So assignment now not now you can copy, because now you have to do the presentation. Presentation now, when the student open the mouth now, we know whether this fellow is copied, whether you know everything. So with the simultaneous, we will have now research scholars for any subject. Actually, we are doing now Thursdays and Saturdays. Thursday 3 hour and Saturday again 3 hour simultaneous. 6 faculty will be simultaneously in groups. Okay, so what are they learned? That